Okay, we're going to talk about section 4.5, which is analyzing graphs of polynomial functions. In section 4, we talked about graphs of polynomial function. And we talked about maximums and minimums. We talked about zeros. We're going to continue analyzing graphs of polynomial functions, even more so than what we were doing before. So, we are going to talk about turning points. Turning points are another name for relative maximums or minimums. And the reason that they're called turning points is because if you trace a graph, you will find that every time you reach a max or a min, you turn and you switch from, in this one, we're increasing here at first. It's going up from left to right. That's what we mean by increasing. And then the graph turns and then it starts decreasing. And then you can see right here at this minimum right here, that the graph turns again, and then at this maximum it turns again. Those are places where it switches from increasing to decreasing. It turns, okay? So then we have this rule that says a degree n polynomial will have at most n minus 1 turning points, okay? So what does that mean? Well, if you have a degree 7 polynomial, for example, then you will have at most 6 maximums or minimums, 6 turning points. Okay, so if we look at this graph, we think, well, what's the smallest degree? Well, we have 1, 2, 3, 4 turning points. So the smallest degree is a 5th degree polynomial. And that should make sense from what we learned in section 4, which was that if it's an odd degree polynomial, the end behavior should be in opposite directions. So if we got like 4 or 6 or something for our degree, we would know that we made a mistake because this the end behavior on this graph is opposite is different in each direction. All right, let's go on to number 1 here. So we're going to graph y equals x to the 4th minus 2x squared minus 2. We're going to find the zeros, the number of turning points, their location, and their type. Okay, so let's look at, let's use Desmos to do this. You can do it with your graphing calculator as well. The commands are a little bit different. I don't have my graphing calculator ready right now, so I guess I'm not going to be showing you on that. But I think I did show you in maybe a chapter 2 video. So here is the graph of x to the 4th, so x raised to the 4th minus 2x squared minus 2. Okay, so I know it's a little bit difficult to see. All right, so here's the graph. And in order to graph this, we are going to plot some points. So in Desmos, you just hit the gear and turn the graph into a table, and then you can pick points from the table. So I'm going to take negative 2, 6. So negative 2, and no, I'm not. 6 is over on top of the graph. So let's go negative 1, 3. Negative 1 and up 3 here. And then I've got 0, negative 2. And oops, sorry. Good job. Should be negative 3, negative 1, negative 3. Excuse me. So ignore this point here. And then we've got 1, negative 3, like this. Boy, I'm really on it today, aren't I? Ignore that point too. Okay. And then I'm going to put the zeros on there. So in Desmos, you just tap to get the zeros. In your graphing calculator, you do second calc 0. Then you pick a point to the left and to the right, and then take a guess, and it will tell you what the intercept is. So we've got negative 1.6, which is going to be right about here, and then positive 1.6, which will be right about here. And so this is what the graph looks like. Something like that, okay? It's not fantastic, but you get the idea. All right, so we want to find the zeros. Zeros are whatever x values make the function 0, which amounts to being the x intercepts in the graph. So this would be x equals negative 1.65 and x equals positive 1.65. Those are our zeros. 2 decimal places is good for Algebra 2, unless it says otherwise. So we've got our zeros. It says find the number of turning points, okay, their location and type. So number of turning points, there are 3 turning points. their location. If it asks you for their location, you are looking for the x values. So their locations are at x equals, and we can just tap those to highlight them, -1, 0, and 1. So x equals -1, x equals 0, and x equals 1 for the turning points. And then last, we need to find their type, okay? And so what I didn't leave myself enough space, but usually what I do then is just write down in parentheses here, this is a min, this is a max, and this is also a min here. Okay, so the type is just minimum or maximum. Okay, so that's number one. Let's go ahead and jump to this box here, intervals of increasing and decreasing. So this is just a nice image that I like to include because it sort of explains pretty clearly what it looks like when a function is increasing, decreasing, and obviously the maxes and mins. So you can see here the function is increasing, then it decreases, and decreasing means falling from left to right, going down from left to right, and then it's going up from there. All right, it's increasing. Okay, so let's find the intervals in increasing and decreasing. I believe this is on the same graph from up above. The window looks a little bit different, all right? But so what I usually like to do is first just highlight where the maxes and mins are. And then on the graph, I'm going to see that it's falling from left to right here, so it's decreasing. It's going up from left to right here, so it's increasing. Going down here, so it's decreasing. And it's going up here. Okay, we are always going, so it's increasing. So once you've labeled the parts, we don't actually ask you to write out the intervals of increasing and decreasing in this section, but you just need to know that what decreasing looks like and what increasing looks like. So if you're asked about a graph, is it increasing here or is it decreasing here, you can analyze it and see. Okay, so then the domain and range. Well, polynomial functions have domain of all real numbers. So you can write all real numbers, or you can use that fancy R like that if you want. But we can see that from the graph because this graph is going to go forever to the left and to the right. It covers all of the x values. All right. The range, that's the y values covered by the graph. And you can see that this graph doesn't have any y values down here, right? It doesn't start to cover y values or include y values until we get to these minimums right here. These minimums are at, I believe, -3. Okay, so starting at -3 is where the range starts. So we can write that the range is y greater than or equal to 3. Okay, next. In the graph to the right, sketch a function based on the following characteristics. So now what we're going to try and do is take some characteristics of a graph and create a sketch. Now there's going to be a lot of different answers, a lot of possible answers that are correct, but that doesn't mean that you can graph anything and have it be right. So let's analyze what we've got here. We want zeros at -1, 2, and 5. So I'm going to just put those points on the graph. So -1, 2, and 5. All right, it has a negative leading coefficient, so we'll deal with that in a second, and it's an odd degree function. Okay, so that means that the end behavior has to be different in each direction. Even degree functions have end behavior that are either the graph is going up in both directions or it's going down in both directions. So if it's odd degree, 0's here, negative leading coefficient. So if it was positive, then you would get something like this, where it was basically the end behavior to the left is going down, to the right is going up, because as x gets bigger, the function gets more positive. But that's not what we have here. We have a negative leading coefficient, which means it needs to start off falling, do some stuff in the middle, and then end falling like that, okay? So let's just sketch in. We know the graph has got to be falling. Going to come back at some point, and you can make these maximums or minimums kind of wherever you want, or as high or as low as you want, and then it's going to end like this. So there's a possible odd degree function, 0's at -1, 2, and 5, that has a negative leading coefficient. And really that wraps up section 5. Section 5 is just digging more into, digging deeper into the graphs of polynomial functions.